Lesson 45 is on integrals of inverse trig functions. So I told you guys to memorize the derivatives of inverse sine and inverse tangent, and you guys did that. All right, now we're going to go the opposite direction. So if we have the integral of 1 over the square root of 1 minus x squared, you have to know that it's inverse sine. Or if you have the integral of 1 over 1 plus x squared, you have to know that it's inverse tangent. So we're going to go backwards. It doesn't mean that any of these could not be on the AP test. Okay, so you might want to memorize them just in case. But for the most part, it's usually inverse sine or inverse tangent. So what we've been doing a lot of u substitutions. So when you see something like number 1, you might think that it's a u substitution one, right? And what I've kind of trained you to do is whenever you see a square root or a power that has something strange inside of it, you usually let that be your u, just like the opposite of chain rule, right? So for this first one, a lot of you guys might try to make u equal 1 minus 4x squared. But when you take the derivative of u, you get negative 8x dx. And, you know, we kind of learned to take that negative 1/8 to the other side. And then when we do that, we get x dx. Do you see why that's a problem here? We have no x in the numerator that we can replace to put the du back in. Does that make sense? So this is not a u substitution one. But when I'm doing the problems, you know, usually if I see a square root, that's the first thing I look for. I look to see if it can be just a basic u substitution where it's the inside of the square root that's my u. Does that make sense? If it's not, then think about inverse sine. Okay, so we want it to be in the form, the integral of 1 over 1 minus u squared du. Okay, that's what we want. Because if we have that form, then we can just do our inverse sine of u. All right, but we have a problem here because we have 4x squared. So when we look at that, you want to think about what is being squared to give you that 4x squared. Okay, so what is being squared? What's being multiplied by itself to give you 4x squared? 2x, right? 2x times 2x gives you 4x squared. That's going to be your u. Okay, so this is like our u squared there. So u is going to be 2x. So when we take the derivative of u, we get 2 dx. So we're going to have 1/2 du equals dx. So as we replace, we have a 1/2 out front and a du, that's what replaced the dx. And then we have 1 over the square root of 1 minus u squared. Okay. But this is a definite integral, so we should really change those numbers as well. So if I have 0 and 1/2, those are x values. Let's change them to u values. So if I have u of 1/2 and u of 0, we want to find what those are. So we go back to this equation, and we plug in 1/2, and we get 1. We plug in 0, and we get 0. So that means instead of going from 0 to 1/2, I'm going from 0 to 1 in this case. Okay, so when I integrate, I get 1/2. I'm going to have inverse sine of u, and the u values go from 0 to 1. So I don't have to go back to x's. I can just keep it as u's because I changed those to u values. And I plug in those numbers. So I have 1/2, and then I have inverse sine of 1 minus inverse sine of 0. Okay, and I fully expect you guys to know how to do that with a calculator. I know that's rough. It's been a while since you did inverse sine, inverse tangent, and so on. Do you guys remember what it means? So basically, when you have inverse sine of 1, what it's saying is sine of some angle gives you an output of 1. But we're very particular about where that angle is. That angle has to be on the right side of the unit circle between negative pi over 2 and pi over 2. We never say like 3 pi over 2. We would say negative pi over 2. Okay? So you're saying what angle gives you a sine value of 1? What would it be? Pi over 2, exactly. So you're going to have 1/2, and then you're going to have pi over 2. Now the next part is saying what angle gives you a sine value of 0? So what angle between negative pi over 2 and pi over 2 gives you 0? 0, yeah. So you end up getting an answer of pi over 4. Okay, does that make sense? Would you be able to do that without a calculator? I have faith. I think you guys can. It's a lot with AP Calc. We talked about this before. You got to know all your Algebra 2, all your pre-calc, you know. It's pretty important. All right, so this one. So this one is not going to be an inverse sine. Do you guys see how I know it's not going to be inverse sine? No square root, right? So it's probably going to be inverse tangent. Again, I looked to see if it could have been just a basic u substitution. So if I let my denominator, my whole denominator, be u, do you see why it doesn't work? Because you'd have 4x cubed. We don't have anything that has an x cubed on top. So we can't replace the du part, okay? So we're going to try to get it in the form. So we want 1 over x squared plus 1 dx, or 1 over 1 plus x squared dx. And these are the ones that I really didn't like very much in high school. Don't you love when your teacher tells you that? Because I didn't like when it didn't have a 1. Okay, this has to be a 1 here. Okay, so it's a little bit tricky, and you have to do a little bit of algebra to make it into what you want it to be. Okay, so that's what we had originally. All right, so if we want it to be a 1, what we're going to do is we're going to divide by 9. Okay, so I'm going to divide on the top and the bottom by 9. Okay, and this is going to change it into x over 9, and it's going to look temporarily very strange. Right, it's looking like this. So we have x over 9, x to the 4th over 9 plus 1, because we had 9 over 9. All right, and I don't usually like fractions within fractions, so if I have x over 9 on the top, what I'm going to do instead is I'm going to pull out that 1/9 just so I just have x there. And then I'm going to think about what's being squared, right? Because this has to be the u squared part. I guess I should say u squared plus du there, but that's fine. Okay, so what is being squared to give you x to the 4th over 9? X squared over 3, right? I heard Jay say it very quietly. X squared over 3. Does that make sense? When you square that, that's how you get x to the 4th over 9. That ends up being your u, okay? So we're saying let u equal x squared over 3. Which, you know, might be easier for you to think of it as 1/3 x squared. Because when you take the derivative, you get 2/3 x dx. So we're going to have 3 over 2 du equals x dx. So as we replace, we're going to still have that 1/9 out front, and it's joined by a 3 over 2 du. On the bottom, I have my u squared plus 1, and that x was replaced by the du as well, so it's going to be a 1 there. Do you guys understand all those substitutions? So 3 and 9 reduced to 3, so I get 1/6. And then this ends up being inverse tangent of u plus c. So our final answer is 1/6 inverse tangent of whatever u was, so x squared over 3 plus c. Okay, so a little bit more complicated. So we have a couple more like that where you have to change that number into a 1. And the same thing with inverse sine. I mean, you might have a number, like this one has a 4 instead of a 1. So for this one, we notice there's a square root, so we want it to look like 1 over the square root of 1 minus x squared, right? Well, let me write u squared. Okay. And it's almost like that except for that 4. The 4 is what's throwing us off. Okay, so when we see that, we need to divide by that 4. But we're not really dividing by 4. It's kind of a trick question. What are we really dividing by? 2. Yeah, because it's under a square root. Do you guys see that? So we're dividing by, it's like a square root of 4 on the bottom, and I'll put a 2 on top. So a lot of people in first period yesterday had questions about like the algebra behind this. So let me show you what's happening. So on that denominator, so like on the numerator, you just have 1/2. But on the denominator, you have, let me not do a big one yet. On the denominator, you have the square root of 4 minus x squared divided by the square root of 4, which really kind of combines into one big square root. Right? Did you see that? So it becomes the square root of 1 minus x squared over 4. Okay, so we're changing this around, and I'm going to have a 1/2. I'm going to have the square root of 1 minus x squared over 4, and then a dx on the side. They also didn't like the dx on the top. Does that bother you when dx is on top? It doesn't matter, yeah. I didn't like it when I was in school, I don't know. Like, I want it to be on the side. All right, so here we go. So what do we think u should be? Yeah, exactly. This should be our u squared, right? So u should be x over 2, which is really 1/2 x. Don't make it complicated and try to do quotient rule or something like that. So du then is going to be 1/2 dx, which is kind of nice because we have 1/2 dx right here. So you could multiply the 2 over and so on, but we're just going to do a straight replace. Okay, so the 1/2 dx gets replaced by 1 in a du. And then the square root part gets replaced by the square root of 1 minus u squared. So it's just simply inverse sine, right? So inverse sine of u plus c. And then our last step is to plug in what u is equal to, which is x over 2. Okay, is that making sense? All right, so what do you think on number 4? What do we need to do? This is what's throwing us off.
Divide by 4.
Yep. So you always have to have a 1 in that spot. All right, so we're going to divide the top and bottom by 4. So when we do that, we get 1/4, 1 plus 9x squared over 4. And then a dx on the side. So see why that's nice having a 4 instead of a 2. All right. So as I make my u, right, my u is going to be 3x over 2, or 3 over 2x. You're basically just taking the square root of whatever's there. So du is going to be 3 over 2 dx. So we're going to need a 2/3 out front. 2/3 du equals dx. So I have my 1/4. I'll put that out front. And I have my 2/3. And then I'm going to have a 1 du. And then on the bottom, I have 1 plus u squared. So when you integrate, you get, let's see, 2 over 12, which is 1/6. Inverse tangent of u plus c, which is 1/6. Inverse tangent of 3x over 2 plus c. Okay. Feeling pretty good about these? The hard part is when they're mixed in with lots of u substitution ones. Like, people just want to use u substitution all the time. They don't recognize that it's one of these forms. So, all right, number 5. Identify your u. Yeah, just cosine. So du is then, the derivative of cosine is negative sine of x. I know it gets hard once you learn the antiderivatives. So we have negative du equals sine of x dx. So as we replace, the sine of x dx is going to be replaced by a negative 1 and a du. And then the bottom, 1 plus cosine squared becomes 1 plus u squared. But this one's a definite integral. It has numbers. So we want to find those numbers. So we're going to find u of pi over 2, and we're going to find u of 0. So we're plugging into the u equation. So we have cosine of pi over 2 and cosine of 0. So cosine of pi over 2, so we're up here. The x value on our unit circle would be 0. Cosine of 0, 1, exactly. So we're going from 1 to 0, which many of you probably don't like. Do you guys not like it when it's like 1 to 0? So if you don't like that, see what we got going on here? We can just flip it. You can make it 0 to 1. And this now becomes a positive out front, right? So it makes it a little bit nicer. There's less like negatives to take care of. So we get that. Yes?
Could it be inverse cotangent?
Yeah, you could do inverse cotangent, yeah. All right, so as we're doing this, we're going to have, maybe that's why they don't put those on there, because it could be either one, right? So we're going to have inverse tangent of u going from 0 to 1. So I'm going to have inverse tangent of 1 minus inverse tangent of 0. And these, you can find both of these answers, okay? I think on your homework, I have one of them on your homework, like inverse tangent of 4. We don't know what inverse tangent of 4 is. Just leave it like that. That would be like an exact value. Does it make sense? You don't have to find the decimal answer. But if you have one of these ones that you can find, then go ahead and find it. So what we're saying is on our unit circle, and tangent is restricted to the right side just like sine. So it's from negative pi over 2 to pi over 2. Do you guys remember where cosine is restricted? Cosine is restricted to the top of the unit circle, 0 to pi. But basically we're saying, what angle do I take the tangent of to get 1 out? So sine over cosine equals 1. Yep, it would be at pi over 4, exactly. So this first one's going to be pi over 4. And then the next one's saying, what angle do we take the tangent of to get 0? So sine over cosine would be 0, so it's going to be where sine is equal to 0 at 0, yep. So our answer is pi over 4. All right, and then the last one. So you could have lots of strange things. E to the x is in there. I just did one that has cosine as the u. So what's our u in this case? What do you think? Is it e to the 2x? It's e to the x, because this is really e to the x squared, right? If you have e to the x squared, you multiply those powers, e to the 2x. So our u is actually just e to the x. So du then is luckily e to the x dx, which we have on the top. So as we replace, we have a 1. We have the square root of 1 minus u squared du. So it's just inverse sine. So inverse sine of u plus c. So your final answer is inverse sine of e to the x plus c. Okay, so you can have strange things that have like e to the x or natural log or something like that in there too. All right.